Hello everyone, good morning. I am Angela Marques. I'm a student post-graduation program Nuclear Science and Technique at the Federal University of Minas Gerais, UFMG, Brazil. My research is related to ray protection and nuclear instrumentation applied to biomedical. The work that will be presentation was carried out in the partnership with professors Amir Zacarias from the CDTN, Rita Sebastião from the Chemistry Department at UFMG, and my advisor Telmo Fonseca, also from UFMG. So, the subject that you will discuss at this conference is this feasibility of new polymeric matrices in the production of ferrous sulphate dosimeters. Also now, like freak gels. About outline, we have a brief introduction to freak gels, dosimeters, the aim of the research, the methodologies applied, results, and final considerations. The freak gels dosimeters have become essential tool in the face of growing demand for the validated methods in high-precision radiotherapy. A high-precision radiotherapy is a sophisticated technique that uses 3D imaging from CT, MRI, and PET-CT to plan target treatment. They are efficient techniques for delivering the dose to tumor tissue while sparing healthy tissue. These dosimeters can be applied as phantoms to their equivalents to immunity tissue and also as radiation detectors. According to the Dean, gel dosimeters are divided in three classes: freak type gels, the object of investigation in this work; radiochrome ones, which are films with the ability to steadily sensitize when radiation, and cross-link polymers, which solidify after radiation. In general, the freak gels correspond to class of dosimeters in which formulas relate a solution of metal ions immersed in a viscous matrix. The chemical response of this device is associated with the oxidation of ferrous ions, and ferric ion is described in the equation below. You have Rn Fe2+, sample that offer radiation produce Fe3+. Its coloration is intensified as the applied dose value increase, as shown in the figure. That way, the aim of this work was to investigate the feasibility of use different polymeric matrices. We have a carboxy metal, cellulose sodium salt, CMC, agar-agar, GGU, and the polyvinyl alcohol PV in the production of ferrous sulphate dosimeters. For tomorrow, porcine sky gelatin extensively investigating the right rope was used as a reference. About the methodologies, freak gel is a prepared from an acid solution containing ferrous sulphate, also known as more salt, sodium hydroxide, which has the function of reacting with impurities in the medium. Cyanide orange with red, with iron forming the chelate agent. Tridistal water that use solubilize the reactant. This AC is a 50 mol sulfuric acid. After preparing the aqueous solution, the matrices are immersed in the middle. For 80 matrices varied amounts were testing the production of the freak gel. For 80 matrices, the sample were subject to cobalt-60 radiation field, and after 1 hour, readings were taken using UV visible equipment. About those calculations, The experimental dose response of freak gel dosimeters is obtained through the mathematical calculation demonstrated below in equation 1, after matrices by UV visible. About results obtained. At first, analysis was carried out in the UV visible region to identify possible without absorption bands, as well as to assess the behavior of different polymeric matrices, gel, CMC, GUG, and PVA solubilized only tridistilled water. As can be in the figure 3, no absorption bands were identified in the visible region in the 400 to 800 nanometers range. It can be seen that GUG matrix showed the highest spectral intensity. This behavior is characterized by the fact that this polymer is still translucent polymer, showing a high absorption in signal. The PVA and CMC, on the other hand, showed a very similar scan the water dew, a 3 water dew distillate. So, in addition, a spectral was carried out for different matrices radiated at 20 grays, showed in factor 4 the presence of Fe2 plus and Fe3 plus species calended with xylene are is identified in the 435 and the 585 bands respectively. Look the GGU spectrum absorption at the 435 nanometers is no clear the band. This is related to characters of this gel, which tends to saturate around 30 gray, indicating the depletion of Fe2 plus. Another parameter evaluated in relation to the jelly matrix was the different concentration. It's now that varied the concentration of these matrices directly influence the experimental dose response. The figure 5 describes the influence of concentration of the different matrix radiation 10 and 30 grays. The best response were recorded for the following concentration is a 50% for the porcine skin gelatin used as a reference is very responsive with a concentration 0.9% for CMC, 1% for GGU, and 10% for PVA. This choice was based on the experimental response, which showed uncertainties of less than plus some more 0.04 is the demonstrated in table 1 is better response for different concentration the matrix. Another parameter evaluated was the response as a function of dose. The data shown in the figure 6 correspond to a slope of the lines that were fitted to the experimental values for 80 matrices investigated. They range from the 0 to 30 grays, indicates the sensitive to radius dose of group of dosimeters prepared of different concentration of the gel. It can be seen that dosimeters produced with the GGU matrix show the great sensitivity when compared of dosimeters doped with the other matrices, reproducing the same linearity already mentioned in the right works for the pig skin gelatin. The last parameter evaluating the work was the stability of the freak gel. As shown in the figure 7, the sample were monitored for a period of 8 hours after the first reading, under refrigerated conditions of 30 centigrade. Analyzing the spectrophotometric profile of the ferrous sulphate dosimeters doped with different gels, was possible to observe a slight intensification of the disturbance signal over the period study. Its characters of a freak gel that the oxidation process of ferrous ions continue after irradiation. Consequently, this affected the response of the dosimetry system. As shown in the table 2, even with the continuous oxidation of the ferric species, the average dose determined experimentally was approximately 4 gray plus minus 1 point for the matrices studied during this period. This is considered acceptable for this device. Final consideration: these matrices incorporated in the freak gel solution were tested experimentally, demonstrating reliability in the measuring of radiation dose. The parameters evaluated of the different gelling matrices were decisive for the understanding these new formulations. You can therefore consider that the freak gel dosimeters constructed from the polymeric matrices reported here have achieved the objectives they set out to actually show reliability with good dose response. Thus, freak gel dosimeters can be proposed as additional radiation detector and also as functional equivalent to simulators of the organ at risk, and can be used in the calibration of radiotherapy equipment. So, these were some of the references used in this presentation. I would like to thank the fund bodies and institutions that allow this work to be carried out: UFMG, FEPMIG, CAPES, NPK, and CDTN, especially the Game Radiation Laboratory. This is my research group, the professors Thelma Fonseca, Amir Zacarias, Rita Sebastião. Here are my contacts for any questions that might arise, and thank you all very much.